Okay, so let's start. We are now in the week 8. Today is 19th of September. Uh, so since there was mid-semester today, um, all I want to do is uh, I'm going to do almost completely the workshop of the future week, so week 9. So that will be very helpful for you. So And also this will allow us to be in advance 1 week. So next week, as a result, we will be able to the future week workshop as well. So this week's workshop is about the function, reviewing the definition of the functions, uh, doing some questions. Then, more importantly, we will review the topic about recurrence relation. So we will see the definition of the recurrence and all right, I'm recording. All right. So we will see how we are able to solve some of the recurrence relations. Okay. So uh, we know that if you have any question, please interrupt me and ask your question. So we know that, so let's assume that A times B. You see here, so this is a Cartesian product. Okay. So briefly just reviewing the Cartesian product. So A times B, the members of A times B are those ones that they are ordered pair AB, which the first component belonging to the first set and B belonging to the second set. So for instance, A uh, is 1, 2, B is 1, 3, 4. Therefore, A, B will be 1, 1, 1, 3, 1, 4, 1 by 1. So, and 2, 1, 2, 3, 2, 4, which are written here. And you see that if we see this graph is like 1, 2. So 1 is related to 1, 3, 4, and 1, 2 is related to the 1, 3, 4. So maybe we can put arrow. Okay. All right. So any subset of this Cartesian product is called relation with from the set A to set B. All right. So from set A to set B. So relation, you see that I have chosen like the orange underline guys, 1, 1, 1, 3, 2, 3. This is a subset of R is subset of A times B. Okay. So also this plot, this figure reminds you this complete bipartite graph to K2 comma 3. Okay. So among the subset of the A times B, among the relations, among the relations, there is one special one, which is called function. Function, in fact, is a kind of relation. It has some condition. First of all, the the members of the first set should be involved. Okay, that's number one. So there should be arrow or lines should go out from this 1 and 2. These are the members of the A. And Also, there is another important condition is this one. If I have one, it should be specifically one member for the first component. So second component should be unique. So like this one. So if A goes to B1 and A also goes to B2, they B1 and B2 actually should be the same. So in other words, I should not see such scenario here. So from here, in here, it's from the initial set, it goes outside just 2 times. So it's not a function. Okay. So also here, this case is also even worse. From 1, it has gone outside 3 arrows. Okay. All right. So this is one thing. A figure about the function can be like this one. 1, 2, 3. The destination part B is A, B, C, D. So you see that from any one, it is going outside just one time. Do you see this dashed line here? This should not exist. In fact, I don't want to see such scenario. Okay. From 1 going to A and B. In other words, sometimes if I press the laptop's button F, so then sometimes the output, it shows the letter F in your screen, and sometimes it shows G in your screen. So this means there is something wrong in your laptop. Okay. From your high school, you remember that F, we show it from A to B. So as I said, F is kind of relation. So F is A times B. F is the subset of A times B. But since it is a special relation and it's function, so we show it like this one. And we say that F maps from A to B. Okay, so the first set is A domain. The second set is codomain. Okay, destination set is called codomain. And the values that F takes, F of A, F of X, it is range. So here you see that 1, 2, 3 is the domain. A, B, C, D is the codomain. But here is the thing. The range of F is just A, B, C. The D is not included in the range of, so F of X or range, B is the codomain. So F of X is always subset of codomain. We have this one always. Doing question 1, part A, we see that A1, A2. Okay, so part A, this is A. It's written here. B is all those natural numbers less than 4. 1, 2, 3. Okay. So what is this one? A1, A2. Okay. So A goes to 1, A goes to 2. So since I emphasized earlier that for being function, we should not see such scenario. Okay. So this is this one. We should not see this one, but here we see from A, the output sometimes 1 and and sometimes 2. So this means it is confusing. It's not functioning properly. So part A is function. Beg your pardon. This is the future workshop. Next week workshop, it will be very helpful for you. Yes, but you should concentrate. Hopefully you won't need to watch my recording videos, but you are welcome to come back and watch it anytime. Sorry. Uh, I am not workshop 7, 8, 9, 10. So maybe four more. Yeah. What about what's your question? Sorry. YouTube. No, in YouTube. The Canvas doesn't have that capacity to upload many videos. I sent email. Do you receive my emails about the recording videos? Okay. All right. So part B, 1, 3, 2, 2, 3, 1. Let's write that one. 1, 2, 3. So it is possibly this is a function subset, which is a relation between subset of B times B. B is 1, 2, 3, 1, 2, 3. And you see that from here, 1 goes to 3, 1 goes to 3, 2 goes to 2, 3 goes to 1 here. So we don't see such scenario. Therefore, that's a function. Part C, we see that natural number times natural. So product of this one, partition product of this one, this is R times R. Natural number times natural, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3, and to the infinity. So this one, for me, it's enough to see just 1, 1, 1, 2. So this is not a function. So this is not a function. Part D depends, A. So it's not one, two sets. The function should be the subset of the A times B. I mean, product of two sets. If we have A times A inside parentheses or the second and third one inside bracket, well, it will be a product. It will be the function. But here we can't. We can't say that. But given that in part E, we see that A times A, it's inside parentheses. We count this one set, and second one is the one another set. So this will be a product function, and it's just one single. A, the first one is an input, and the third one is the another input. Okay, so that's why. So this E is function, but D is not a function. Okay, just a moment. I'd rather come here. I So just tell you that we do future workshop. Uh, when I while I'm teaching, I recommend you to take a note. Okay. All right. So question 1 is done. Okay. So let's move. Okay. So not all the functions are the same. Some of them are one-to-one, some of them also surjective or onto. And if a function is both onto and one-to-one, we call it bijective. It's important to understand, especially one-to-one function and by inverse function, because one-to-one function means inverse, surjective is onto it, so it gives you the bijectivity as well. So to have a better view, you can look up the application of the one-to-one function in computing or in computer science. You can see applications, algorithms, flow charts. Yeah. F is one-to-one. You can see this definition here. If f of A1, B1, f of A1, A2, then A1 should be equal to A2. But don't worry about this one. This is algebraic or mathematical definition. F is one-to-one if you don't see such scenario. If we do not see this scenario, okay? And F is onto, and also look at this one. If f of A1 equal f of A, contrapositive. If A1 is not equal A2, then f of A1 is equal to f of A2. Onto, we say that the range is equal to codomain. We know that always onto function covers all the codomains member. In other words, codomain should be equal to range. We know that if f of A from here, A to B, so you see that this goes to here, this member here, but there is a single element here. It's alone. There is nothing has been related to this. Anyway, if this one is A, f of A is those numbers that have been related to something from the domain. So f of A is always inside B. But if f of A is equal to B, this means onto or surjective function. So f of A is always subset of B. To prove that this is equal, you need to prove that B is subset of f of A. Okay, how do we do this one? Usually, to prove that a function is one-to-one, especially using this one and especially using the contrapositive version, it's easy. But proving the onto function for the students are a little bit difficult. With my experience, I know that. So with the knowledge that f of A is always B, so you just want to prove that B is equal to f of A. Well, that's why you will say that you will take one element from B and you will prove that that element belongs to f of A. Okay, so how? Well, you will say that you have got for each B belongs B. For any arbitrary B belong B, you will say that B goes to f of A. For any for all B belongs B, you will say that prove that B belongs to f of A. To prove this guy, so assume that it is this one. To prove this part here, you want to know that B belongs to f of A means B is equal to f of something A. To prove this part, you want to say that there is an A in the domain X such that the above is happened. So let me write again. Okay. So we will find A such that this is correct. So if F affects A or acts on A, it will be equal B. So this means B will be belonging to F of A as well. So this means surjectivity. Question 2 says that prove that the function is bijection. What does it mean? It means prove that f is a function, prove that f is one-to-one, prove that f is onto. F of x equal to 2x plus 1. If x1 is equal to x2, then 2x1 is equal to x2. This means adding plus 1 both sides, it will be 2x1 plus 2 plus 1. From here, f of x1 plus equal to f of x2. But this is easy function. This is reversible. From here, you can go here, minus 1 divided by 2, you can get. So this is a function which is also one-to-one. Let's do onto function. Let y belongs to the codomain. We wanna prove this box. Y belongs, here B is R, A is R. Let's say y belongs to the destination or codomain is an arbitrary guide. So we want to prove that y belongs to f of R. In other words, we want to prove that there is a belongs to R such that this happens. Well, if this means if f acts on A, f of A will be equal to y. Okay, y equal f of A is equal to 2a plus 1. To prove this one, to find this one, A, which this one is happening, we know that f of A is equal to 2a plus 1. Okay, we know that this will happen. We just don't know with what A. Well, we know that 2a plus 1. From this equation, we can find a 2a plus 1, a equal y minus 1 over 2. Well, if you write until here, you will get your full mark. But, and in some books, most of the books, it's written until here. But in some of the valuable books, they write more. What does it mean? To age deeply. Well, what is the meaning of this one? Well, this means if you act f on A, f of y minus 1 over 2, what does f do on this? It's doubling this one plus 1. 2 times this guy, which if you cancel this one, y minus 1 plus 1, it will be y. So we found an A from the domain such that if f acts on that, it will give y. It will give the y to you. So this means y belongs to f of A or f of R in this case. So this means f is also surjective. Is there any question about this? Okay, so question 3. If f function is one-to-one, then f is invertible. I will finish soon. If function is one-to-one, f is a relation subset of A times B. We said that function is a special relation which is subset of A, B. The elements of F in fact they are A, B. What's the inverse? Inverse means changing the place of A and B. Okay, this one. Okay, we say that F inverse is definable or exists if we said that a function we should not see this one. Well, if you have like this scenario in your function, when you invert it, you will see this one. Therefore, you should not see this scenario in your original function. Therefore, the function inverse will be, you won't see like this one. Therefore, your function should be one-to-one to be able to define the inverse function itself. Okay, and you can look up also application of inverse function in computer science. So composite function means GOF. Firstly, F acts on input, then G acts on F of X. So you see that if X is input, it comes to firstly F of X applying on the X. So F of X is an output, okay? And G will apply on F of X. So the output will be G of F of X, okay? From here, we see that the range of F of X should be inside or subset of domain of G. So that's why I have written this one here. If the range of function is something that G is not in the domain of G, well, it cannot be input of G. So it won't work. So to be able to define this composite function, you should have this condition, okay? All right, so let's move on. Now, question 3, we wanna say that which parts of which function here are, which relation are function or not. We see that this one, first one, we don't see this scenario for the function. So it's a function. In the domain, the arrows to the destination set, we don't see such scenario. So it's one-to-one function. And we see that all the destination members, they have been covered as well. So this function is also surjective. Here, we see that one, we see this scenario, we should not see. Well, then it's not function. We see this one here, so it's not one-to-one, but it is onto. So not function, not one-to-one, but it is onto relation. Usually, if the function is not, if a relation is not a function, it doesn't work to analyze that, to investigate that, whether that function is one-to-one or onto or anything else. Function not onto or not one-to-one. Here you see that this is a function because we don't see such scenario. You should practice these things so you won't get confused. But we see this one here. It's not one-to-one because we see this scenario. And it doesn't cover 2. If you want to remember that, if which one? Well, we can remember the function version easily. How? You see that on your laptop, you press 1, and in the monitor, it shows sometimes 1, and it shows sometimes 2. This means your system is not functioning properly. So this means this is the case that we should not see this scenario for the definition of function. So not function. The second reason that it's rejecting is that it's not covering all the domains members. So it's not function really. It's one-to-one relation. It's onto relation. Okay, you can do J and K by yourself. Part B says that calculate FOF. FOF, F is coming from here. FOF1, F of F1, F1 is 2. Why? Because F1 goes to 2. F of 2, according to this figure, F of 2 goes to 1. It is also written here. So FOF, and similarly, it will be 2. So I wanna try, so KOF is also written here. FOK, F of K1, K1 is 1, F of 1 is 2. F of K2, look at K2 is 3. F of 3, but 3 is not part of the domain, so this is not definable. So all I wanna say, it doesn't have this scenario. So it should have R, K has to be subset of domain of F, but it doesn't have this. It doesn't enjoy from this property. Now I wanna do IV J or J. What is the domain of J? Well, it's 1, 2. J or J of 1 is equal to J of 1 equals to J of J1 is 1. J of 1 is 1. Now, J or J2 is equal to J of 2 equals to J of 2 is 1. J of 1 is 1. So this is definable. This one is done as well. Just make sure that domain of the second function should be hyperspace or hyperset of the first, range of the first one, or range of the first function should be subset of the domain of the second function or outer function. All right, is there any ambiguity or is there any unclear that I can explain more? Question? Okay, question 4. If one wishes to prove that a function is injective, instead of using this guy, we can use the contrapositive. So decide why two definitions are logically equivalent, because if to Q is equivalent to negation. Q goes to negation. Part B, use contrapositive. So f of n to n. Let m is not equal n. Then, so you can assume that m is like less than n or m is like less than n. Then we see that f of m two times n less than 2n, 2 times m more than 2n, which is equivalent to say that f of m is less than f of n, f of m bigger than f of n, or greater than f of n. So anyway, this one usually it's easier than this one. It's easier than this one, so you can use this one. From the contrapositive version. You are going to get the Bachelor of Computer Science. Am I right? So you should have a tiny knowledge of mathematics, so the life will be easier for you as a computer scientist. Otherwise, you will do your job still, tasks, but well, you won't, it will take some time for you. Okay, now the main topic of future week is recurrence. So next year you will have algorithm course. It's important to have this course. So this course will help you to measure the complexity of your pseudocode. Once your pseudocode is algorithm, like to optimize, or you change your code to claim that your pseudocode works faster, I should confess that it depends on the system and the language programming and the hard disk. If it is SSD, it's better. What's the other storage name, which is not SSD? Yes. So SSDs also will help you to run your code better, faster, I mean. System, if it's Linux or Windows or Mac, which one is better? Which one is help you to run your algorithm faster, Linux or Windows? Linux? Okay. Programming languages. Now, which programming languages are faster? Java. Okay. What about C++? Okay. Huh? Fastest one. Okay. Is that a Python, Julia? Then we can work on MATLAB. All right. Sometimes some languages, but if you want to develop something, what about C sharp? C sharp is probably for what? Which task is better to use C sharp? Streaming? What's that? Okay. Okay. And also, does it depend on the editor as well? The place that you write your programming. No? You guys are studying computer science. I tell these things because I want to learn from you guys. Of course, you are first semester students, but you expose these things, so you increase your knowledge now. Any editor that you use for your Java? Huh? Excellent, excellent. VS Code, Visual Studio. What else? How do you write it? Spider, don't talk about the dangerous things. Spider is good. Okay. How do you write spider? See, spider editor. This one. What's yours? Eclipse. IDE, Eclipse IDE. What's the IDE stand for what? IDE, what was it, IDE? Where do you write your Java? VS Code. What's the IDE stands for what? IDE, what is IDE? So what can you write in VS Code? Is it free? Okay, number one. Can you write several languages in it? Okay. Can you use Copilot in it? Are you cheating sometimes as well? Oh, okay. What's Copilot doing? You don't, Copilot is better than ChatGPT, but I usually, it's not better. It's better. Okay. For me, sometimes I forget the syntax things, so that's, but the main thing is coming in my brain. So I use my brain, but VS Code, can you write what languages should I? So imagine that I have got VS Code. What should I? Do I need to install Python in it? So okay. What about HTML code? I think HTML is already inhibited in it. Huh? Okay. It has Java already inhibited in VS Code. Do I need to install it? But that contradicts what I said. Okay. Again, do I need to install Java in VS Code? Has it already inhibited in VS Code? But you say that to both of my questions. Yes, yes, they contradict each other. Okay. Again, does it have already VS Code? VS Code does already VS Code have the Java in it? Yes or no? Okay, it doesn't have Java inside VS Code already. I need to add it. Okay. Who? What, do you have websites, profiles for yourself? Yes. What about you? Do you have profile for yourself because you are doing computer science? You you don't have it? Not not yet. Excellent. A good question. A good answer. What about you guys? Yeah, website. A lot of assignment doesn't allow you to create a website. Yeah. What about you? Okay. Huh? Have? Okay. Rather, hi. Do you have website? You are talking about website profile VS Code. Do you have website? What's that? Can we visit your website? Yeah. What about you? Do you have website? You guys, what are you doing? But you can try firstly by what are the which websites. Some of them they provide a free one. But then after you can pay. It's not in Australia. It looks so because of the expenditure and incomings, it is cheaper. But one thing, is Copilot free to use? Okay, okay. So with the university student email, you can create a free premium version of. You can use the premium version of Copilot. Yeah. But if you don't, once you are not students, okay. Can you use just 1 year or 2 years? Okay. If you have your own website, say imagine that you create something, you write something in Python, but you need online compiler. Where do you use it? How do you use it? No, no, no. See, you have created your own website, okay? You have written some HTML code and Java. How do you want to compile it online? So in the 24 hours, 7 days, 24 hours, you cannot be online. Okay, how do you want to do that? Mhm. Cloud. Oh, excellent. I just wanted to hear this. Where do you want to use it? Cloud? Uh-huh. Okay. Can you use Amazon website, Amazon Cloud for 1 year for free? 1 year for free. So it's important to learn cloud, okay, these days. Okay. Sometimes you see that the trend is with learning machine learning, then deep learning, then so it's important to learn cloud now. Maybe next year or 2 years later, you will have to learn something else. Okay, so let's move on. Recurrence relation, it's good for measure your complexity of your pseudocode. Okay, so you see here, this to find fn, it's depending on the one previous, and this one is two previous terms. So this is called Fibonacci recurrence. So 0, 1. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 8. 5. It's like this one. It works like this. So recurrence, it depends on the previous terms. You can write it, but sometimes it's possible to solve it. What does it mean? You can have the explicit version. It's only depending on n. Let's see. Question 5. F0 and F1, they are called initial conditions. It's like same as differential equation. So question 5a, you see that here, A1 is 3. A0 is 1. A1 is 3 times A0 equals A0 is 1 equals 3 times 1 is 3. A2. A2 is equals to 3 times A1 equals to 3 times 3. Okay, because A1 was 3. 9. A3, 3 times A2, 3 times 9, 27. We can write a couple of the terms from Bn as well, Sn as well. Let's see this one. An is only depending on one previous. So the order, we want to define the order of the recurrence, okay? So the order of this recurrence relation is 1. When we have recurrence relation, we should have initial condition. Otherwise, we cannot find it. What's the difference of Bn and Bn minus 1? In terms of indices, it is just 1. Bn, B sub n minus 1. Okay? So, well, Bn is only depending on one previous term. Sn is depending on not only one previous term, but also second previous term. So the order of part C recurrence relation is 2. You just learned these things today, and you don't have to study anymore on your weekend. So this week's workshop is just 13 questions, and you can handle it very quick, easily. So part D, n minus 1, n minus 2, n minus 3. What's the order of part D? What's the order of part D? What happened? It was easy notion, but since you did not concentrate, you did not learn. What's the order of Sn? Excellent, because you were just watching the video with one eye. Even it helped you. But the other guys, they were not watching. So Sn is 3 because it depends on one previous, second previous, and third previous. Okay. And also you can say from this, how many initial conditions does it have? S0, S1, S2, 3 of them. And obviously, the order of the last part is what? Is just I said. I just said that how to find it. What's the order of this recurrence relation? What's the order of this recurrence relation? Yes. Why?
There are two values of P.
Because Tn, let me amend you that it's just depending two previous, or it has got two initial condition. Question 5 is finished. It says that a solution to recurrence relation is a formula that gives Sn directly in terms of n, not depending to the previous terms. Okay? So this is called solution or general solution for this. It says that question 6, what is the solution of the 6a? We see this one here. A0 is 1. A1 is 3. A2 is 9. A3 is 27. So for me, An is like 3 power n. If I substitute by n equals 0, it will be 3 power 0. 3 power 1 is 3. 3 power 2 is 9, and so on. So the answer of question 6a is this one. And it says that the box, if the initial condition changes, the solution of the recurrence relation will be changed completely. So imagine instead of question 7a, it says that if in question 5a, instead of a0, instead of being 1, if it is 0, well, we can see that a1, what's a1? A1 will be 3 times a0. Here, use the formula. 3 times a0 is 0 because it says that change from 1 to 0. 3 times 0 is 0. A2 will be 3 times A1, 3 times 0, it will be 0. A3 as well will be 0. So the sequence will be 0, 0, 0, which is quite different with the AN being equal 3 power n. Question 8, it says that the general solution is the one that it captures all the initial conditions. So it says that solve the recurrence relation without initial condition. If you have got initial condition, okay, you can solve it. You can get the particular solution. But if you don't have, if you don't have initial condition, then you will have general solution. The general solution includes not only n, but a constant coefficient. That constant coefficient varies depending on the initial condition. Okay, here you see general solution for this one. A0 is 8. Okay. A1 is 3. So let's assume that in question 8 it says that find the general solution when this one. There is no initial condition. The initial condition, let's assume that it's A. So A1 will be 3 times A0. A0 is 8, so 3A. A2 will be 3 times A1. 3 times 3A, 9A. 3 power 2A. A3 will be 3 times A2. A2 is already 9A, so this will be 20. So AN, the general solution for question 5, part A, without initial condition, it will be A times 3 power n. So A times 3 power n. If we don't have solution of the recurrence relation, then we need to use the recurrence relation. If we don't have solution, then we need to use recurrence relation. See this one too. So let's read this guy. A recurrence relation is called case order. When the difference. So we have done question 9, the order. But I want to talk about something else. See this one, 2, 5, 8, 11. What are their difference? 2 and 5? 3. The difference of 5 and 8 is also, and the difference of 8 and 11 is also 3. Okay. So you can see that we can use this relation. Tn is equal to Tn minus 1 plus 3, T0, 2. We have seen this one in the proof by induction. To obtain, let's say, T power T sub 100, you need to calculate T99 plus 3. Then for T99 itself, you have to compute T98, then 97. That's why it's called recurrence. If we write pseudocode for this one, to be able to implement it in any language, input n, t initial condition 2, for in the loop. I from 2 to n, t is equal to, let's write it, let me amend this one. Also, so you guys, what are you talking? Okay. So for n here, output t. So this will, if I give here 100, if I run it, it will give us the T100. But instead of this one, if we have a tiny knowledge of maths, we know that this is arithmetic progression. So we can write Tn. Since it's starting from T0, this will be ND. Otherwise, if it starts from this index from 1 T1, I will just write n minus 1 times d. So Tn will be 2 plus 3n. So I can just calculate T100 easily. 2 plus 3 times 100 will be 302. Okay. The difference of general solution or solution and recurrence relation is like this. Okay. Is there any question about this? So we just finished 9 questions. Totally, the workshop of next week is just 13 questions. So I expect you guys, you will be able to get 4. It's the action notion. Once you sit in your workshop, you should start solving your questions from question 11, 12, 13. Focus on them. Ask a lot of questions from your demonstrator. Huh? Oh, yeah. 11, yes. 11, 12, 13. One thing, last week here, did you watch the YouTube video that I recorded? Yeah. What about the recordings of the last week? Were you here last week? Okay. So if you were here concentrating, you didn't need to watch my report. But do you remember that I said that this question is important? It will be in the exam as well. And they were exactly that one. Actually, I was seeing the questions here, but it was not for me ethical to tell this. For me, it will be bad if you guys, if you don't pass. This in College of International will ask me, I will be under the question. So you should better study. Huh? Graph. Graph. Well, it was in my recordings. I said that there will be Hamiltonian. Okay. Huh? Pass rate 56. Huh? your overall more than 50 days. So 30 decimals. Diamond is just 5 or 10? 10. See, you have another assignment. But mid-semester was the most important. And what about this one? For workshop exam, each of them, each board what? Listen. Oh, concentration. Okay, I have a question. Did you concentrate? I was teaching. No, it's, I just asking. Okay, question 10. Question 10 is just nothing. It says that you can see the recurrence in the real life. CSN is a complete graph. It is asking us to understand SN, the number of the edges of the complete graph. A complete graph is all the possible edges between the vertices without bridges and loops. S1 is the one vertex, 0 edge. S2 is just two vertices, one edge. Three vertices, four vertices, although it's not planar, but six edges, three edges with S3, S5, 10 edges. It is asking that what is S1? S1 is like this one. How can you express Sn in terms of S sub n minus 1? Imagine that it's n minus 1, Sn minus 1. If you add new vertex to this one, then how many edges you should draw to get the new graph as complete graph? Well, one vertex, how many vertices do you have here? N minus 1 of them. So you will have to add n minus 1 of edges. So the general solution will be Sn will be, this guy will be previous number of the edges of the previous Sn minus 1 plus n minus 1. And the S1 is 0 here. You can write S2, initial condition. You can write S2, one of them as well. Okay, this is the answer of question 10. Yeah. S1 is just one vertex and there is no edge. Okay. How can I express? I explain. So imagine this circle is just like one graph with n minus 1 vertices. So it has got some number of the edges in it. It's not important. So if I add the nth vertex here, so I will draw the edges to the n minus 1 vertex. So I will, then I have to add n minus 1 edges. So I depicted here what I explained. So you can give this, so a vertex with a graph, complete graph with 1000 vertices. How do you do that? Computers are good in repeating stuff. You will run this. Now, important, so you will have one question in the final exam. Calculating the, so you will, so until question 1 to 10, maybe you can review. If you are sensitive, in the first session, I said that don't study. If you concentrate during your class, you don't have to study. But if you are sensitive and if you are worried about your marks, well, just review this question 1 to 10. During your workshop, just start working from question 11. Okay, so let's solve this one. We have plenty of time. It is convenient to be able to classify recurrence relation because they are some we have general methods to solve. So recurrence relation, if we classify them in terms of homogeneous or non-homogeneous, okay, linear order of them is important. If they are linear or not, constant linear, it's easy to solve. So if Sn is like something like this, constant coefficient linear homogeneous will look like this one. Sn, A times Sn minus 1. Sn times, if it is second order, it will be like this one, like Fibonacci. Third order, like this one, constant coefficient, A, B, C, A, B, A, B, C. Linear because each SA term occurs in the first power. Power S. Homogeneous because only terms involved are SI. There is no plus 2 plus 1. Let's go back question 5. Is it linear? Yes. Constant coefficient? Yes. Is it homogeneous? Yes. Because there is no plus 5 plus n. It's just depending a n minus 1. Is it linear? Yes. Is it homogeneous? No. Plus 1. Is it linear? Yes. Sn minus 1, Sn minus 2. Is it constant coefficient? No, because of this n here. Is it homogeneous? No. Sn is this one part D. Is it linear? No, because this power 2 here. Is it linear? Yes. Is it, what's the order? Second order linear, constant coefficient, and homogeneous. If it is homogeneous, it's easy to solve. If it is non-homogeneous, it's difficult to solve. You will have non-homogeneous question in your exam. Focus one time and you learn it forever. Classify, we did. Question 12. How many questions do we have? Okay, so 12, we are going to solve it. It is teaching us the notion how to solve of the homogeneous. Question 13 is deal with the non-homogeneous question. Okay. Question 13, look at the instruction here. It's about non-homogeneous version. This one is going to teach us how to solve homogeneous equation. So it says that this one is Sn minus 1 Sn. So what happened to question 11? Did we solve it? Yes, I solved. But you were not paying attention except these two guys. And he's playing with the phone, he's with himself, and you sometimes look at, but not continuously, discretely. The meaning of discrete mathematics. Okay? And that guy is also paying attention as well. Sn, but when you talk, not only disturbing your friend, but also sometimes it's bothering, annoying to him as well. Sn, this one, constant coefficient. linear homogeneous. Yeah, because there is no plus 2 plus 5. Guess what's the, for some reason, if it is differential equation, the answer will be e to the rx. For recurrence and natural numbers, the answer guess is x power n. Let's add this one. Let's guess. Consider this one. This is the constant coefficient linear homogeneous. Okay, a method that allows works for the type of a problem and it's as follows. Okay, so guess this one. Okay, we will guess. We get, so Sn is x power n. This will be x power n minus 1. This will be 2 times x power n minus 2. So it's written like this. Very perfect. Okay, divide both sides by what? Not n minus 1, it's typo, n minus 2. Divide both sides by n minus 2. Okay? There is a problem with it. To get the polynomial equation called the characteristic equation, in this case, quadratic. So if I divide this guy, it will be x power n, x power n minus 1, x power n minus 2, plus 2 times x power n minus 2, minus 2. So if I simplify this one, it will be x power 2. This will be x. This will be 2. So x2 minus x minus 2 equals 0. So let's erase this. Okay. Did you understand up to this part? You got it? Do you have a question about this? X2 minus x minus 2 equals 0. Yeah, you got it? All right. Then find the okay. If r is the root, so this will be the solution of this one. So let's solve this one, and taking a suitable combination of these exponential solutions, details to come will give the most general solution. Follow the above from I to II, okay? So I will do that. Let's solve this one. What's inside the square root? What's that? Yeah, excellent. So 1 plus minus 3 over 2. 1 plus 3, 4 over 2 is 2. 1 minus 3 is minus 2 over 2 is minus 1. So it says that if we solve this one, if r is the root, okay, r power n will be the solution of this one. Let's see. Sn minus 2. Okay, so that's correct, yeah. So let's see. R power 2, so this is R. This is R. Let's see Sn equal 2 power n is the solution of this one. Let's see. 2 power n minus 1 plus 2 power times 2 power n minus 2. From here, 2 power n minus 1 plus, what's this one? Power n minus 1. And how many 2 power n minus 1? 2. 2 times 2 power n minus 1, which is same as 2 power n. So left side is equal to the right side. Thus, left side is the equal to the right side. Okay. If you write Sn equal minus 1 power n, this will be the equation. Let's test minus 1 power n plus 2 times minus power 1 minus 1 power n minus 2. So from left side, so minus 1 times minus 1 power n minus 2 plus 2 times minus 1 power n minus 2. Did you understand what happened here? Okay, so I wrote this one. If you have a question, just let me. So this part, same as this part, then they are addable. 2 minus 1 is 1. 1 times minus 1 power n minus 2. But my minus 1 power 2 is positive 1. So 1 times this guy. So this will be equal. If I combine, multiply them, left side will be equal to right side. Which part? How? Because minus 1 power 2 is 1. Yeah. Which one? This one? Yellow? Minus 1 power n minus 2. So see this one. Minus x plus 2x is equal to 1x. Okay? 2 of this one minus of this one, it is 1 of this. So what, huh? What is minus a plus 2a? Same as 2a minus a, which is a. Yeah? Okay. So it says that if we have two solutions, let's study this one. Taking suitable combination of these in the test room. Follow the above to find the characteristic equation. Okay, so this will be Sn, the constant, 2 power n plus b times minus 1 power n is the solution of Sn. Why? Well, Sn minus 1 plus 2 times Sn minus 2. From here, let's do this one. Sub a to n plus b times minus 1 of n. A times 2 power n plus so first one n minus 1 n minus 1 plus twice of a times 2 Okay? Yeah. So I did like that. So if I gather A's in one place, 2 power n minus 1 plus 2 power n minus. So there is a 2 here, so I will times 2 here. Times 2 power n minus 2 plus b minus 1 power n minus 1 plus 2 times minus 1 power n minus 2. We know that guy is equal to this guy. This guy is equal to this guy. Why? Because we see that because of this. The green one because of this. So A times 2 power n plus B times minus 1 power n. So the right side is equal to the left side. So if you find two solutions, the linear combination of the two solutions will be same. Okay, so if you find more than one solution, show that Sn, A times solution 1, B times solution 2 also satisfy the recurrence. Okay. Did we find more than two solutions? Yes. R power 2, R equal to R minus 1. The characteristic equation was, this guy is the characteristic equation. Did we show that each of them? Yes. This one is the solution, first solution. This one is the second solution, is this one. So we had two solutions. That's right. Sn equal to 2 power n, Sn equal to 2 minus 1 power n. We show that the linear combination is this. Yes. Choose your favorite initial condition. Favorite. This means how many Sn is A times 2 power n plus B times minus 1 power n. Since Sn is order 2 because it's depending on n minus 1 and n minus 2, we can choose any two arbitrary. It's a so S0 something 1, S1 for example 2. If we have S0 equal 1, S1 equal 2, then we can find A and B. I just chose initial conditions by chance. Okay? To solve for A and B. So Sn for Sn minus 1 plus 2 summarize this guy, solved this one. The general solution will be A times 2 power n plus B times minus 1 power n. It says that choose two initial conditions, S0 equal 1, S1 equal 2. What's the meaning of this one? S0 is A times 2 power 0 plus B times power 0 equals to A plus B, and S0 was 1 in our choice. S1 equal this power 1 plus 1, 2a minus b. So simultaneous equation a plus b equal 1, 2a minus b equal 2. Elimination method, 3a equal to 3. From here, a is equal to 1. Therefore, b is equal to 0. Why do we get b 0? If I put a equal 1, b will be 0. So the particular solution relying on this initial condition is Sn is 2 power n. That's it. Okay. Let's choose different particular solution. One. No, let's choose 3. So this will be 3. This will be 3. This will be 3. So this will be 4. This will be 4 over 3. And b will be 1 minus 4 over 3 will be minus 1 over 3. So in this case, Sn will be 4 over 3 times 2 power n minus 1 over 3 times minus 1 power n. Remember that you will do these things much complicated next year in the algorithm course. Question 13, it's dealing with the characteristic equation. Okay, so an last question. For each of the following linear homogeneous it's not about non-homogeneous. Non-homogeneous, you will deal it with it like next week. So what's the characteristic equation of this one is n minus 1, n minus 2. Look at this one. It needs your concentration. R power 2 equals to 5r minus 6. What about this one? R power 2 1. What about this one? R power 2 4. R minus 4. So let's solve part A. It is R power 2 minus 5R from here, R minus 2, R minus 3. Therefore, R equal 2 or R equal 3. So what's the general solution of A? An equal to A times 2 power n plus B times 3 power n. What's the general initial condition? A go to A1 equal 5. So let's apply this n equals 0 to this and n equal 1 with this. A times 2 power 0 is 1 plus B times 3 power 0 equals to 2. A times 2 power 1, 3 power 1, 5. A plus B equal to 2A plus 3B equal 1. Let's do elimination method, but before we need to times this one. Times it by -2. -2A minus 2B -4. 2A plus 3B 1. 3B minus 2B is B, and this one is 1. And if I use this guy here, I will be able to get that A is equal 1. Therefore, AN equal 1A 2 power. What was the R? 2, 3. 2 power N plus 3 power N is solution. What about, let's write the characteristic equation of R2. This one is easy. Part B, so let's add pages. T squared equal 1 equal to plus minus 1. So Tn is A times 1 power n plus B times minus 1 power n. This is equal to A plus B minus 1 power n. T01, T1 minus 1. T01, what's T1? Minus. This one is A plus B times minus 1 power 0 is equal A plus B is equal to 1. Equal A again B times minus 1 power 1 equals to A minus B is equal to minus 1. So again A minus B minus 1 elimination method. 2A equals 0. A equals 0. And since A is equal 0, B will be 1. From here, Tn is, I'm going to update my general solution. It's here. A is 0, B is equal 1. So this guy is minus 1 power n is the solution of Tn equal Tn minus 2. Is that so? Yes. With the initial condition of T0, 1, T1 equal minus. Last part C. This guy. R2 4R minus 4. From here, R2 minus 4R plus 4 equals 0. From here, R minus 2 power 2 equals 0. From here, R equal to repeated root. Yeah. Therefore, let's have a look at the table. If it is this one, Sn, so the answer of question 13 part C, it will be Sn A times 2 power n plus B times n 2 power n. What's the initial condition? 0, 1. R. What's the xn? Sorry. Xn A times 2 power n B n 2 power n. Initial condition x0, x1, what were they? 0, 1. 0, 1. X. So let's use these two initial condition. A times 2, 0 plus B times, luckily we get 0 equals 0. So this will be 0 because B times 0 is 0. So this is 1. So A is 0. The other one, A, 2 power 1 plus B times 1, 2 power 1, 2A plus 2B equals 1. A is 0. From here, B is half. So xn is equal to, so I'm going to update my equation here. Half times n 2 power. Okay, so I finished the questions. Just a moment. All right, do you have a question? Okay, I am ending the recordings.